In this video, I'm going to solve this question. A linear regression model y is equal to alpha plus beta x plus epsilon is estimated using OLS. It turns out that the estimated r square equals 0 and we have to check what does it imply. Now first things first, note that it is small y here and it is small x here. Well, for notational convenience, I'm replacing this with capital Y and capital X. So I'm writing that our simple linear regression model is capital Y is equal to alpha plus beta capital X plus epsilon. And note that I'm doing this just for notational convenience. And this is how I'm defining my small xi. So I'm saying my small xi is equal to xi minus x bar and my small yi is equal to yi minus y bar. Now we are given in the question that estimated r square is equal to 0. We know that r square is equal to correlation between y and x whole square. So it is equal to correlation between y and x whole square. So this is the definition of r square in a simple linear regression model. And now we know that this implies that r square is equal to summation xi yi divided by under root of summation xi square multiplied by under root of summation yi square whole square. The term inside the bracket is the correlation between y and x. Now let's manipulate this formula a bit. This implies that r square is equal to summation xi yi whole square divided by summation xi square multiplied by summation yi square. And now I'm dividing and multiplying this equation by summation xi square. So I'm writing it like this. Now note that we know that beta hat, which is an estimator of beta, is equal to summation xi yi divided by summation xi square. So this is the formula to calculate beta hat. Now note that this and this, like if we combine these two, then it's nothing but beta hat whole square. So that means we can write r square is equal to beta hat whole square multiplied by summation xi square divided by summation yi square. Now we are given that estimated r square is equal to 0. Well, if it's equal to 0, so r square is equal to 0 implies that either beta hat is equal to 0 or summation xi square is equal to 0. Now this is straightforward that beta hat is equal to 0. Let's see what does this imply. So if summation xi square is equal to 0, as per our notation, this implies that summation xi minus x bar whole square is equal to 0. Well, this implies that variance of x is equal to 0. And this is because this term here, like this term, is the numerator of variance of x. So if this is equal to 0, then variance of x is equal to 0. And variance of x equal to 0 means that x's are not varying. This implies that x's are constants. So this implies that your x's are constants. So this means that if r square is equal to 0, it implies that either beta hat is equal to 0 or the x's are constants. So that means our right answer is part C. So beta hat equal to 0 or all x's are constant. And this is all for this question.